This video is going to show you how to do a simple regression in Excel. So we have this data set of all 50 states and the median household income is my dependent variable. I want to see if I can predict income based on all these different ones. Now in Excel, you want them to be close together. So in each of these tabs, I actually went through and changed all the information so that all the columns are together. So let's start with household income by population. Let's see if I can predict household income based on population. The idea would be bigger populations would have more income. Maybe, maybe not. So I'm going to go to data, data analysis, and regression. And then I'm going to put in my data. So I'm going to go up to my Y is my household income. And my X is going to be population estimate. I did not include labels for either one of those, but you could, just make sure you check this. And then I'm going to put my outcome on the same page right here. If you don't, it will default and it will open up into a new tab down here. Either way is fine. So I get all of this information. And let's go through and start looking at it. So this is my R value. So if I have an R value of 0.07, this is very weak correlation and like no relationship. It's pretty bad. In fact, less than 1% of income can be explained by population. Not good. Not good. So then I'm going to look over here. This is going to say significance F. And this is going to be the ANOVA table. I don't care about any of this, but I do care about this guy right here. So what this guy right here is telling me is that the model is not significant because it is more than 0.05. So 0.61 is way more. The model is not significant, meaning there is no relationship and you cannot predict income based on population. So let's look at a different one. And I did the exact same process, but this one actually has a relationship. So here we're trying to predict household income by the percent below poverty. It makes sense that these would be related and probably a negative relationship. So the more of the population that's below poverty, the less household income you would see. So if we looked at this first table, again, we have the R value right here is a 0.85. So this is a strong relationship. And we would have to look at the graph to see direction, if it's positive or if it was negative. We'll be able to see it down below too. So here we are going to be able to say that 72% of income can be explained by the amount of the population that is below poverty. I will note right here that the 50 is your sample size. So I had 50 states included. I want to make sure that I included all 50 states. That's just kind of a quick data check. So over here, again, we're going to now say it was a strong relationship, but is it significant? And in this case, this is crazy significant. In fact, there are 15 zeros before that 5. So it'd be 0.0000000000000000509. So this is definitely significant. Which means we're going to scroll down. And again, we've got all this other stuff over here that we're not really focused on. We want to find out about these coefficients right here. So this right here is what we're going to focus on. So this intercept, that is our beta 0, And this x variable, that is our beta 1, specifically this number and this number. Remember how I said we're trying to just find the numbers to make the equation. So in this case, we're going to say that income equals our intercept, so 80 plus, in this case, actually, it's a minus. So that shows us that it's a negative relationship right there between the two variables. So this 0.08 or 0.85 up here is a strong relationship and it's negative. And if we saw the graph, it would be a negative relationship. So we're going to say minus, in this case, 2.5 times below poverty. And we could now use this equation to predict a specific state, or to predict a county, or to predict other things similar to it.